welcome back to Mountain Minds Monday, a program of Tahoe Silicon Mountain. I am your MC for the evening. My name is Ellen Rayner, and I'm on the board of Tahoe Silicon Mountain. So I'd like to thank our gold sponsor, Holland and Hart. Notice we have just one gold sponsor now, so we are looking for more sponsors. That's what allows us to continue to do the live stream, and you'll be able to tell all your friends who missed tonight because they were watching the Warriors elimination game. They'll still be able to see this if they check it out on the YouTube channel. So in addition to our gold sponsor, we have community sponsors who help make this happen. And so that includes DLL Technologies, the Nevada County Tech Connection, who's been helping us out with the live stream. We have the town of Truckee. We have the Truckee Airport, the Lyft co-work space that hosts some of the events that we hold. Pizza on the Hill, who graciously hosts us here. Thank you to Tahoe Donner. And the Truckee Roundhouse. Hope some of you made it to the Maker Faire yesterday. Okay, so this is where you contact us if you'd like to become a sponsor. So do that or ask me after the program. Thank you to our individual sponsors. This is a program we put in place about 2 years ago, so you can become an individual sponsor. That gives you entry to all the Mountain Minds Monday events. It gives you the pizza and salad and either a beer or wine or 2 sodas. And you have a special check-in line. You can jump the line to get in. So it's a good deal. We are a 501c3, and we'd love to have you as individual sponsors of the Mountain Minds Monday event. So on to the main event. I've been really looking forward to this talk. I saw a documentary about the railroads over at the State Museum back in the winter time, and I've been counting down, even changed a flight to make sure that I was here for tonight, so I'm super excited about this. Our speaker tonight is Jerry Blackwill, who I think was at the very first Mountain Minds Monday back when it was just Tahoe Silicon Mountain 9 years ago. So Jerry is the president of the Truckee Donner Railroad Society, and I think I heard some of the cohort here. Jerry's also a member of the new Museum of Truckee History and member of Truckee's planning group for the 150th anniversary of the Golden Spike. I think he'll talk about that at the end a little bit, some of the other events coming up. He's done research and made presentations about the transcontinental railroad, the Truckee to Lake Tahoe Railroad, and the area logging railroads. He also teaches economics at Truckee's Sierra College. He holds degrees from UCLA and University of Chicago. And our own local star, Jerry, thank you.
Well, thank
you. I guess you have your own.
I have my own, but I need the little clicker there. Yes, that's the magic thing. And let me see. Yeah. So what I wanted to talk to you tonight about really is the 150 anniversary of the Transcontinental Railroad being completed, which is really a big deal throughout along this whole railroad. And probably Truckee is doing more in terms of talks and things like that. And I'll talk about that later. But tonight, I'd like to give you sort of the evolution and how locomotives have changed over the last 150 years. And there have been relatively large changes. If you look at this picture, this is the Promontory Summit, Utah, 150 years ago, when the Central Pacific and the Union Pacific completed the Transcontinental Railroad. They came together just north of the Great Salt Lake, and it was a big deal. These railroads had been building for years, and the Union Pacific had it fairly easy going across the Great Plains. The Central Pacific, which is a railroad that came from the west, from Sacramento, it was working a little bit harder, and they had to go through a few bits of solid granite to get over the top of the Sierras. So, so we're playing tech games right now, and okay. this wasn't a high-tech event, why I'd really be concerned, but I know that these things don't happen at high-tech events like this. Well, the old locomotives actually... Okay, the old locomotives, on a really good day with really good track, these things, I'm going to go back one. Are we? Not yet. Okay. So these old locomotives would do 60 miles an hour on really good track. And the Central Pacific Railroad and the Union Pacific Railroad were in a race. And they were out there to lay as much track as they could to see who could get the most government land along the right-of-way and the like. And so as they were going faster than anybody should go fast, they weren't spending a lot of quality time on laying the track and making it ready for somebody to go 60 miles an hour. So if they got 15 miles an hour out of those trains, those locomotives, why, they were doing quite well. And so that was really a major effort for these trains, and but they did get them going. They got the whole thing in operation, and
we're going to get a new projector.
Okay, and so. Do we have it on the other one? Okay. So this is more fun than I normally have. So what I'm going to do is paint word pictures for a while until we get Dell to go away. And we're talking about the old locomotives, and these old locomotives actually came together, and the Transcontinental Railroad was completed. And that was a huge engineering project, one of the biggest engineering projects of the 19th century, really a very, very important one. And so that was 150 years ago. 60 miles an hour on a really, really good day, good track. 15 to 20 was about the way they went. And really what happened 150 years later has been some big, big changes. And I'll show you some pictures later, but these changes had to do with not just the nature of the track, and the actual nature of the track has been changed in looking like it's going through changes. And but it's the power, the whole power system. It's a system called magnetic levitation, and that's not really too spiritual. It's just the levitation means that they're using magnets that oppose each other, and they go on up. So they have two magnets of the same polarity, and they raise the track, and then they have other magnets down the center of the track that actually move the train along. The difference in speed between the 150 years ago and today, the Chinese recently had a Maglev train that was operating, and this Maglev train actually achieved a speed of 370 miles per hour. And I'll be talking later about trains that go even faster than that. But that was one of the really big events. This train, and the Chinese are doing a lot. They're moving really very, very fast. If you look at the Chinese, the Japanese, and the European nations, they're far ahead of the United States in the technology of passenger trains. And they have some advantages. One of the things is the parts of China, certainly Japan, and many parts of the European, the Europe really itself, are much closer together, major population centers, and so that gives a big advantage. And so that's where you see big changes in the trains and in the way things are going, and so far so good. Okay.
Making progress.
Yeah, and as far as I know, Dell doesn't have anything to do with railroads, but they're getting a very nice commercial right now, and so we're moving around. That screen, that was going to have, and so we're going to talk about that, and then the next thing I'll be talking about. Oh, here we are. We've got it.
We're making progress. We're going to need a razor.
A razor. I used a razor this morning.
How many should we use?
There we go.
No, I think we need the screen. We need the screen. Okay. This is the fifth talk I've given on railroads since really almost May 10th, since things started. And this is by far the most exciting. I never have all this happening before. And so it really is interesting. Actually, between those, oh, here we go. We seem to have lost the Maglev train, but we did get a portion of the two trains coming together at Promontory Summit, Utah, and that was a big parade, and that was a big event on May 10th of this year. They really redid that again, and of course they did it in color that time. So that was really quite nice. Here we go. Oh, there's our friend Dell again. Okay. So this is sort of like when the Tony Awards start, and they just slowly come down, and in the meantime, while we've got the audience all happy and joyful and all that stuff. What is about to be revealed to you is a picture of the Chinese Maglev train that did 370 miles an hour. He said, you know, where the hell did you get this one? Yeah, and well.
Too bad, because the top of the slides are good, but the bottom are not.
Okay, so I think I'll just work through with the top of the slides. Okay, I'm going to move along with these slides just in the interest of time. This locomotive, which you can sort of see here, now I do need to have more of that locomotive showing. This locomotive is distinctive for Truckee itself, because this locomotive was back in the days when locomotives first came out. They didn't necessarily have numbers, they actually had names. And this was called the Antelope. And the Antelope, the distinction here, it pulled the first passenger train to get to Truckee. And this was in 1868, June of 1868. And so when this train came through, they had started very early in the morning in Sacramento, and they sort of worked their way up the hill, stopping at every town of any significance at all. Of course, the politicians loved to make their speeches, and they were making them. They stopped at Truckee, they made their speeches there. Finally, at 9 o'clock at night, they got to Reno, and that was the end of the run. And what was really distinctive about that, they'd been waiting for the tunnels to get cut through the top of Donner Summit. And they had almost 15 tunnels from down by Sacramento all the way up past Donner Summit to, actually Coldstream Valley, those that you know that. And the tunnels along the way, they'd been working, one tunnel, Donner Summit Tunnel, they'd had to work for almost 2 full years to get that thing blasted through. And it was a major effort. And one of the things that the railroad had done, because they knew they were in a race with the Union Pacific, and yeah, that's getting better. Okay, well, now I lost it. Well, I can do it one by one on that basis.
Hey, stop there.
Yeah. So this is the Antelope, and it's a little bit hard to see. It's a little bit squished, but it is a good example of a wood-burning locomotive that they used 150 years ago. And a couple of characteristics of this that are sort of interesting. Some of them all has the same characteristic that all steam engines have. This silver part here actually is a big water tank. And through that water tank are pipes, 30 or 40 different pipes that go down into the firebox here, where they have wood that's thrown into the firebox to keep it going. And then this heated air goes through the water, heats the water up to the point that it's steaming, just as you would in a tea kettle. And then the hot air goes on out into this little chamber and then goes on up into the smokestack. Wood burning engines that have a smokestack are distinctive because this has a certain turbulence that occurs as it goes up this really wide smokestack. They hope that a lot of the embers would come on down, throw through that. Then they had a mesh on top that hopefully would get more burning embers. And so they really tried to reduce the chance of fires along the right-of-way. Then the heated steam actually went up into a little dome right there, and that dome would capture the steam itself, and then through a series of pipes would come down to that cylinder that was in front of this whole drive assembly. There was a system of valves up there that would, the way they were open would determine whether or not a little shaft here went one way or the other. And then these really pretty complex series of shafts and things like that, rods that actually propelled the train. Fairly complex piece of machinery, really. And, oh, that helps, sort of. Hello. And so this was, well, if you want to stop there, I could talk from this one. This is another part of the talk. This is an example, hello. This is an example of the firebox that I was just talking about. These are the heated tubes that had the hot air that went through a covering that was covered by water. It then went up into this here, which is a dome, and then the steam came on out and went on down here to these cylinders and ran the train. So that's essentially how a steam engine works. If you want to see one in operation, there's a locomotive called the Glenbrook, and the Glenbrook is really a distinctive locomotive and has a lot of impact for us here in Truckee. The Glenbrook actually ran passenger trains from Truckee here down to Lake Tahoe for people who were winter tourists. It actually started out life as a logging train, and it pulled logging trains from Glenbrook over on Lake Tahoe up to Spooner Summit, and then the logs were put on a flume, which shot down to Carson City to the Virginia and Truckee Railroad, where they were put on trains again, and then they went on up on their eventful trip to the Virginia City mines and were used to shore up the mines. When the ore ran out, why then they started using that on this rails that went from Truckee to Lake Tahoe. And one of the problems on steam was that really needed a lot of an infrastructure. And the infrastructure itself consisted of water tanks. And there were water tanks along the whole track at every major and minor town. And of course they needed that because all the steam that was powering the engine would then go out of the cylinders when it was dissipated. So they lost all that water. And so they had to replenish every few miles at a water tank. And so when you saw a steam engine based track, railroad, well, you saw that. The other problem that steam engines have is they're unidirectional. They really pretty much go in one direction. And so in order to get them turned around, when they needed to turn around, they had to use turntables. And so you'd see these turntables, and you have turntables in many of the divisional places, a lot of the smaller towns. Truckee had a turntable, and there was also a turntable up at the top of Donner Summit. And and what would happen is when a train came westbound, got to Truckee, why they knew it was a steeper grade. They were going to need extra locomotives on that train. So they pulled them out from the yard there at Truckee, from the maintenance facilities, and then they hooked them up to the train. They took it up to the top of Donner Summit, and they unhooked them at Donner Summit, and then they took these back down, and then the westbound train took an easy slide down the mountains. And one of the things that happened is these locomotives started out pretty small. You could see they were fairly short, the early ones, but they began to get longer and longer and longer, more complex. They actually would have 2 sets of cylinders on them, getting really quite complex. And as they got more and more complex, more maintenance. But the other thing that happened was these long locomotives going through the sheds and the tunnels up here at the top of the Sierras. The smoke would come out of the front of the engine, come on down, and starts choking the engineer and the fireman. And that wasn't a very popular thing for the engineers and the firemen. So as one enterprising engineer who said, well, you know, I'm going to see what happens if I turn my locomotive around and push the tender first, and I'll see how that works, if that works going through the tunnel. Well, it did eliminate the problem of the smoke, but the other problem they had was they couldn't see very well over the tender. And so he went back to the executive offices in Sacramento there, and this was when the name of the railroad had changed from Central Pacific Railroad to Southern Pacific Railroad. So he went back to the Southern Pacific offices and said, you know, maybe we could make an engine that we actually turn around like this and put the cab in the front. Well, it turned out that they were capable of doing that because by that time, oil had been discovered in California, and they started using oil to fuel the Southern Pacific locomotives. And so Union Pacific would have had a problem doing this because they had coal back in their tender. These guys had oil that would then flow through the pipes to the firebox right there. And once it got to the firebox, then it acted just like a regular locomotive. And so it turned out to be one of the most popular locomotives, not just going over the Sierras, but as the other parts of the Southern Pacific started to see these locomotives, they had a lot of really better visibility on the line that Southern Pacific had down to Los Angeles and the line that they had on over to New Orleans. And so they began to use these all over the Southern Pacific line. So the cab forwards were essentially an invention that was really prompted by the fact that we had a bunch of tunnels over the Sierras. And so that's really what got things going. Well, okay. Are we okay now? Okay. Whoop. This is so exciting. I never know what I'm going to see on the next slide. Okay, are we there? Okay. This locomotive over here is probably the zenith of steam locomotives. And this was a locomotive that was used by Union Pacific. Finally, Union Pacific started using oil as well. But this particular locomotive had had its service life ended. Was sitting down at a museum in Southern California. About 4 years ago, why Union Pacific bought the locomotive for a very low price, and then they actually hauled it up on their own tracks all the way to their big steam engine maintenance, locomotive maintenance facility in Cheyenne, Wyoming. And in Cheyenne, Wyoming, they rebuilt this thing, essentially almost the whole thing, redid the boiler and did all sorts of work with the goal of having this locomotive operational for the 150th anniversary of the completion of the transcontinental railroads. And it was. And so they actually took it out as close as they could to Promontory Summit, Utah, which was Ogden, Utah. And the reason for that is the railroad that used to go all the way through Promontory Summit, Utah, essentially went around the Great Salt Lake. And Southern Pacific decided, hey, it's a lot easier if we just build a bridge across. So now there's a bridge across Promontory Summit, Utah. If you go out there, there's a nice tracks right there where the locomotives come together and things like that. And if you walk about 200 yards either way, there's no more tracks because they just left it just as a display. So this was a big deal, seeing it. I don't think we're going to get to see this locomotive here in Truckee. I was talking to the head of publicity for Union Pacific here in California and asked him about it. And he said, no, he didn't think they'd get it out here. And there's some fairly good reasons, because they're never quite sure if it's going to keep operating all the way, and they don't want to get it that far away from Cheyenne. There is another locomotive that is a smaller version that's turned out to be pretty reliable. Its number is 844, and that locomotive actually has been out here to Truckee before, and we'll probably see it this year. The people who make the schedules for these steam locomotives, they're sort of conservative. They're not sure that everything's going to be working right, and so they have a short time frame on their schedules. So we talked about a lot of these sort of problems on maintenance and things like that with steam locomotives. So along comes the diesel locomotives. And this is a picture of the Southern Pacific trains in, I believe it was 1975, going through the old tunnels that used to have track in them up at the summit. And in 1995, why the Southern Pacific decided that we're paying too much property tax on having these tracks laid through here. So we're going to rip them out, and we'll just use a long, newer tunnel that goes right out near Mount Judah. It's a 2-mile long tunnel. And so they did that. So this tunnel, these tracks no longer exist, but the diesel locomotives did come along, and so we had diesels. Let's see, did that work? No, not quite. See if we can get that one. This one. Okay, this is a picture of the way a diesel locomotive works. And it's pretty straightforward in a lot of ways. If you look at it, it has a diesel engine that runs a direct current generator that then run electric motors that actually run the wheels. Some of you may recognize this. This is very similar to a Lexus hybrid, except there's a gasoline engine there, and it's not quite as much power. But this is that was how they did it. That's how they built these, and they call them really diesel electric engines because they are both diesel and electric. And the diesel engine just generates electricity for the actual power. And so then when you compare these two, the diesel and the steam have about the same power. They have about the same pulling ability. And so, but there's a big difference in the maintenance required. The diesel engines have a very good uptime. They're about 95% available when they're ready to run. The steam engines, if things are going right, they're talking something like 35%. So there's really that, it made it almost a no-brainer for most of the railroad executives to say, okay, we're going to go diesel on this. And that's, in fact, what they end up doing. So let's see if we can try the next one. This is so exciting. Okay, talk a little bit about train control systems. And this is started one of the earlier train control systems. The really earliest ones were extremely simple. If you had a single track, well, you'd have a train that was set on a siding waiting, and if there was a baton sitting there at the siding, that means that the train had gone through and they didn't expect anybody else going. If there wasn't a baton, they had to wait until another train came through. So it wasn't what we call high tech. And then they begin to slowly get higher tech. They begin to put in these semaphores, and when they first put them in, they were simply semaphores that were activated by levers at the bottom, and somebody would find out through the telegraph that a train was coming through, and then they'd put them up so they stopped trains coming the other direction. And then as that got more sophisticated, why then they were able to make them work remotely from the station. And today they actually make these units. They're no longer semaphores, they're just lights, red, yellow, and green, but they actually run these from a central point. And for the Union Pacific, it's actually Omaha, Nebraska. There's a big control room there. This is really the wave of the future. This is a European passenger train, high-speed passenger train. Gives you a little bit of an idea of what the cockpit on one of these things look like for the engineer. He's got video screens, plus he's got computers and things like that. So that they really are coming along with some fairly advanced things. Now, in the case of the United States, they've come up with a concept called positive train control. And positive train control is a whole system of running the operation. And what they've done here is they've actually tied them in with satellites, GPS systems, and the GPS system will give them some position information. And then they also have changed a lot of their voice radio lines to data lines, so they can actually exchange data between Omaha, Nebraska, in the case of Union Pacific, and they can actually, in some cases, slow the train down or things like that. They still have engineers and conductors on these trains. If you see a train going through Truckee here, there are two guys up in the front. There's some question of why they need two guys, and there are actually some tests that are being run on the East Coast to see if they can just do it with a single engineer who simply is monitoring the system. And of course, the signal system themselves, that will continue to work. There's a little bit of a problem in GPS in that the accuracy of the GPS is not good enough to tell them which track the train's on. So they have to supplement that with some other positional information, and they're able to do that. And positive train control really just came in December when it was finally implemented. The rules were such that they had to be implemented by this last December, so that's what they did. Getting very, very close to the possibility that they might be able to run that totally without anybody. Can we go up? So here is the we're beginning to look at the future here. This happens to be a German railroad train. It's got the power comes through the top through a system of wires and things like that, and a what's called a pantograph that goes up and makes connections with the wires. And so this runs pretty quickly. It'll go 150 miles an hour or so. So they're doing fairly well. Again, the Japanese who are whipping along, and they have a test track where they have maglev. And I don't know if you remember the picture of the Chinese train, but they had it up to 370 miles an hour. So of course the Japanese did 375 miles an hour. But one of the things about maglev trains, they don't use rails anymore. They have to have a series of magnets. So they have to use the test on a total thing. So this is a test operation in Japan that they're doing. So let's see if we can get the next set of. Okay, in Japan, they have actually had high-speed trains going back to 1964. And they've really done quite a job with that. I don't know, for those of you who have been in Japan and had a chance to ride the high-speed trains, they are really quite awesome. And it's a little, you have to be careful because they stop, they open the doors, and you better be on that train, because it's very, very fast and moves right on. I had ridden one, and we got out, and I was just standing waiting for a slow train, a local, and all of a sudden I heard this 747 that was coming right down the tracks, it sounded like. And I looked up, and it was one of these high-speed trains. They ran them through the middle track so people wouldn't wander out on the track. But this thing just zooms, and it is very impressive. Well, I talked about, do you really need engineers and conductors in a train? This happens, this far picture here, this is a picture of what's been termed a robot train. There are no humans on this train at all. This is a train that's run in Australia by a mining company, Rio Tinto Mining Company. And it goes quite a distance. It goes 500 miles, goes from the mines, goes to a port, and then the cars are dumped into the ship that's waiting for them, and then comes back, and it does the whole thing without humans on board. There are human operators watching the system at different places. But this is probably the first totally automated train that's used on a commercial basis in the United States, in the world. But they do have those going, and so it's really a major impact here. One of the reasons they're able to do this, I don't know if any of you have been through the Australian outback, but there's not a lot of people and not a lot of cars in the Australian outback. So it's not quite as dangerous as if they were trying to run through Truckee that way. So yeah, that's it. Let's see if we can try the next one. Oh, this is so exciting. I never know what we're going to see. Another group that's really, another country that's been doing very well is France. And France has about 17 areas, 17 towns that are tied together with high-speed trains. And a lot of these high-speed trains are economically viable. And when they say high-speed train economically and viable is the total downtown to downtown time versus the airline, because in almost all cases, if you're going to take an airline, you have to take some sort of transportation out to the airport, and it takes you a certain amount of time to get on the plane. And then at your destination, you have to get off, then you have to have transportation to downtown. Where these actually can go downtown to downtown center, so it's much faster. And so these trains, a lot of these trains are economically viable. They do have one really long run that goes from Paris all the way down to southern France and across the Spanish border into Barcelona. That's about a 7-hour train ride, and it's not really economically viable. And the airlines in Europe there's some really cheap airlines in Europe, and so it makes that really a problem on economic viability. But these shorter runs that France has, it works out very, very well for them. But the winner is China right now. And China has more high-speed rails than the whole rest of the world combined. So there you see it right there. They were sort of working on their high-speed rails, thinking about getting things laid up, ready to go about the time that California was thinking about putting their high-speed rails in. China has the whole thing up and operating. Why, thank you. And why not? Oh, I guess I don't. Yeah, okay. So China has the whole thing going. They have some advantages that California didn't have. The government owns all the land, so if they want to go through a farmer's land, why, the farmer gets to move. That's his choice. And so that makes it a little bit easier for them to get things lined up. Not too many lawsuits against the government in China. So that did help a lot. Most of the lines in China are economic. There is one very long one that goes all the way up to the top there, and it's not at all economic. You can get there by plane much faster, but it was a deliberate part of the Chinese policy, because this was an area that had a different ethnic background than the Han Chinese background centrally, and they've really been trying to bring in the western part of China into the central China. And so they actually subsidize that. But they do encourage people to ride the train, and they ride fairly inexpensive things. A lot of these lines that are in the center part are between major cities. They have really huge cities in China. You go in and you say, well, how big is this? Oh, 20 million people, 15 million people. I mean, these are major cities, major population centers. So they are economic. They get from place to place faster than a plane would. There's one that's sort of marginal, and that's the run between Beijing and Shanghai. And that run has about as many airplane flights as it has train trips. And on that one way, it's right on the edge. And so both people use that. So let's go on to the next one. Oh, this is fun. And so the next thing I want to talk to you about is what could be the future. And this is called Hyperloop, and it actually is called Virgin Hyperloop. And this was a concept that Elon Musk came up with. And he said, well, let's not just have maglev. Maglev has a lot of advantages, low friction, and they can get it going pretty fast. You saw 375, 370 miles an hour. But let's eliminate this problem with air resistance by putting it into a vacuum tube. So this is Musk's big idea. And so he talked to Richard Branson, the Virgin Airways and Virgin Train and things like that about this. And Branson said, oh, wow, I like that idea. So he's an investor in the company. Just to give you a little background on how this maglev works, these are magnets opposing poles right here. They be either both north or both south. And so when it's ready to move, why they energize the poles on the unit itself, and actually then the whole train rises up, and there's no contract at all underneath it. So that really eliminates a lot of friction. Then when they start to move, these are alternating north and south poles that just sort of move the train right along. It doesn't go like this, it goes like that. But so that's the big thing. That's maglev. And then the thing that Musk came up with was actually to say, okay, let's put it in a tube and really reduce the amount of air resistance greatly. This has a little thing on how speeds compare, and this shows, this is the Maglev train, and it could get up to 670 miles an hour, but I don't think it will get up that high in regular production. This is compared to a 737. A 737 does around 560, not quite 600 miles an hour. They can go faster, but their bosses say you conserve fuel, and so they go a little bit slower than that. But it goes really just almost the same speed of a 737, yet it could be city downtown to downtown. So it could have a significantly increased advantage over that. So let's try the next. Oh yeah, that's fun. And so if this picture here is actually a test site, and this test site is just north of Las Vegas, and it's a big tube that first Moss got involved with, and then they have another other people who are involved in it. So this long tube, and by long it's like 0.6 of a mile. It's not super long, but that's the one they put in because it is relatively short. They've got up to about 240 miles an hour in this, but so far they don't have people in it. They have a vehicle that looks like that. In fact, that is the vehicle that they've been testing on that. So it's a major test area right here, right next door to us in Nevada. And so that thing really is coming on, going to be I think has the potential to be a very, very interesting means of transportation. Let's go on up a little bit. And one of the plans that somebody, I guess it was Moss himself, suggested that if you put a Hyperloop between Las Vegas and Reno, you could do the whole run in less than 50 minutes. And so if you think how long it takes you to get from Truckee to Reno, you could be, just for not much longer, you could be all the way down to Las Vegas if you want to go to Las Vegas. And so that yeah, that is one of the problems. And then Moss really has this idea of a lot of different other routes. Routes between Los Angeles and San Diego, this route that we talked about, and then a route up from Portland, Seattle. These are things that they're sort of in his mind. They haven't been a really long route from Cheyenne, Wyoming, down to Denver, then on down to Dallas, and then on down to Houston. This is one of his great plans, and a possibility of a route down through Florida, and then other routes up in the Midwest along there. So these are sort of the dreams of Elon Musk and I think Branson as well. So they're looking at that. So let's move this up one. Oh yeah. So is this ever going to be a reality? Well, there were actually 3 people who got involved with these Hyperloops. First Moss, then Branson, and then a sheikh in Dubai. And they've got some money in Dubai, and so that sort of helps things. And so you may have a feeling that they're a little bit ambitious in Dubai. If you look at that shadow right there, that's the tallest building in the world that was built in Dubai. And so they're really seriously talking about this, and I think it could be as early as next year. It may be in 2 years, but they have a very, very good chance of getting that done. It'll be go from Dubai to Abu Dhabi, and it's 85 miles. Today by car, it takes a little over an hour to go on. Once they get this thing operating, it'll take about 12 minutes. And so they really have, if this one goes, and watch the paper and things like that, then you'll begin to see the use of these Hyperloops all over the world. India's, look, yeah. Yeah, they just, they're low, and, oh, I'm sorry. The question was, are they using the same technology? They were pumping the air out of the tube as Elon Musk is using down in Nevada, and they are. And so, yes, that's true. And so this gives you an idea of sort of the future. This could be the future very much. I think maglev is going to be the future, whether it'll be maglev in tunnels or maglev just on the flat, the way Japan and China are going to do it. But I think you'll see that, and this will be whole new rails. The tracks will be gone, and they'll just be magnets that run along there. So, yeah. For the most part, I think, oh, the question was, what are the G-forces on the passengers with acceleration and deceleration? And this is really a computer-controlled operation, so the computer can accelerate at a force where the G's do not exceed what's humanly possible, and on the other side, they don't stop that fast. So that's it. This is what looks like it's going on, and maybe could I take some questions? And I'd like to talk a little bit about the 150th anniversary. So let's pass the mic around, and whoever has a question, raise your hand. And oh my gosh, I answered everybody's question. Oh, okay.
I've got a question regarding 50 years of technology, U.S. technology. Just your first slide compared to what we see here in other nations. And the question I have for you is, with respect to back in those days, using coal to fire a steam engine, where do you see, both as I understand you're an economist as well as a train aficionado, the economic consideration of emerging technology with respect to our need for energy? We went from coal, wood-fired type activities, to diesel, which is much more efficient, and where are we going to grab that energy to be able to move heavy equipment?
So what we're seeing in these changes in technology is really the maglev concept, no friction, because it's really suspended above the tracks, and then if you put it in a tunnel, that reduces the air friction, and so it's a significantly less electrical energy component, and so I think it's going to have a major effect. Another big effect that we're probably going to see in the cities as more and more people quit using their cars. I mean, major cities now like San Francisco and New York, cars are really a headache, and people don't like them. And so as they don't have cars, then they are going to go to public transportation, and fast public transportation will make a big difference. Yeah.
What are the issues with maglev as for people next to the tracks? I mean, certainly, obviously, high speed, you want to keep them off the tracks, but as they approach a residential area or city, are there any issues with magnetic forces? Yeah,
the safety issues on maglev or even high-speed trains are pretty much the same, because high-speed trains go fast enough that they're doing 150, 200 miles an hour and they hit somebody. It doesn't make a lot of difference whether they're doing 150 or 370. Same result for the person. So almost all cases, they are elevated on platforms that are difficult for somebody to get onto the platform.
It's less about them hitting the pedestrian than it is about the maglev forces, and whether that's an issue if you're close to one of these maglev tracks.
Yeah, which is really a good point, and I haven't heard anything about that. And you would think that anytime it's like being in a room with MRI, it's the same sort of thing, and so it could be a problem. Probably in Japan, I think the distances from the maglev track to the nearest people where anybody's living and things like that could be not a problem. I'm not sure how well cell phones will work on these maglevs, and that might be an interesting thing, and which may be a good thing for society. People say we want too much.
Jerry, I don't have a microphone, so perhaps you repeat it.
Oh.
So staying on the same thing, besides just the EMF, the other question is, or sometimes is about noise. So is the noise of the loop much less because it's in this vacuum-like environment?
Yeah, it would be less. In a tunnel, it would be less. But of course, the Chinese and Japanese will be the same sort of noise that I experienced when I thought I heard a 747 come through. So yeah, the noise would be. I think probably the question about magnetic waves is probably one of the big things. There's another thing that they've said is there may be a problem keeping the vacuum for really long distances, but I think that might be able to change by having different seal points, so the whole line is not a vacuum. So but that has been a point somebody else raised. Any other questions? Yes. Do you have a?
Can you summarize the technology for California and the bullet train?
I wouldn't hold my breath. The big problem is big cost overruns. The Chinese, obviously, their workforce is less expensive. Their land acquisition cost is very, very low. And those are two big problems that California ran into. And that's one of the reasons that California probably won't complete this train. There's a likelihood that thing will just end up to be a monument with and won't do much. So I wouldn't hold my breath on California getting high-speed trains. You want to get a mic?
We touched upon that topic of the economics of California financing and China.
Mm-hmm.
I am aware that there is an initiative of a train, which they're calling it the Marco Polo train, which is a project from Spain all the way to China, transcontinental across the entire Asian continent. Do you have any insights as far as how they're working that and collaborating across all these different nations to be able to facilitate that?
Well, the right-of-way is pretty much there. The Trans-Siberian Railroad goes all that distance. And once you get to the western part of Russia, there's train lines there, and I think they could probably put something like maglev along that right-of-way. I think that's doable. There's a funny thing between the Russian trains and the European trains, in that the European trains have slightly smaller distances between the rails than the Russians do. And I always thought it was so when the Germans invaded Russia, they'd have to change the wheels. But I think that's just the way it worked out, that they do it. And that's not a big major thing, especially if you're going to replace it all with magnetic rails. Right? It would. So yeah, that's a possibility. And it's a big capital cost. I mean, these things obviously cost a lot of money. So I don't know how fast that will go. Yeah. There you go.
Last year we rode the high-speed train between St. Petersburg and Moscow, and they're using German technology.
Yeah. Well, those, they are, that's an area, a length that would make sense, that they could in fact be competitive with airlines on that particular. So there are a lot of places in the world, just as we looked at this map that even Moscow came up with, that they really would be technologically improved, and they would be useful. One of the stories that was on here was a little video about why the United States doesn't have high-speed trains. And it talked a little bit about some of the things that happened early on in some cities like Los Angeles, where General Motors, the predecessor to Chevron, and I think it was General Tire and Rubber, got together and decided, it'd be a good idea for us to buy up all these electric lines, and then we'll just close them down. And that's essentially what they did in Los Angeles. And then they went up to Sacramento and said, gee, look at the traffic. We've got to build freeways. So they started building freeways and building freeways and building freeways and building freeways. And so that's one of the problems that happened there. And actually that model was used in a lot of other cities throughout the United States. So so the road beds were actually lost at that time. And so Los Angeles, as an example, is building a system of not high speed, but electric cars and things like that underground. So that is happening. But that's one of the things that prevents these trains. The other thing is just the distance through the west. From Chicago to the Bay Area, it's really more economic and faster to get on a plane and just fly. And so the advantage, the only reason people ride those trains almost as a tourist, just to see what it's like going through the mountains, because it's not economically viable. And so that we may never see too many of those long lines. You may see that line between Reno and Las Vegas if they thought there were enough passenger traffic on that. You probably would see a line between San Diego and Los Angeles. I'm sure there'd be enough traffic on that. And probably between Portland and Seattle, there should be enough traffic on that. So those things, I think, will end up going. And so any more questions? If not, oh, go ahead.
You've been talking about passenger trains. What about cargo? Is there a future there?
No, I don't. I think the kind of cargo that you'll see on these trains are sort of the kind of cargo that you see on airplanes, because there's a limited space, and I don't think there's going to be that much cargo going on. When the one in Dubai to Abu Dhabi, they say, okay, we'll have cargo capacity, so they can put cargo on it. But I don't think that'll be a major thing, and so that was sort of it. So now I'd like to talk about the 150th anniversary, just talk a little bit about that. And so if we could have another set of slides. We have a group. Dave is a member of our group that we're working together to really plan events to celebrate the 150th anniversary of the transcontinental rated train being completed. And so we really have over 24 talks. We have walks and a lot of other related events that to sort of celebrate the fact and give people an idea of what the railroad history here in the area is. And these events are all staged either here in the Truckee area or up at Donner Summit in that area. And so this little list, which is impossible to read, it gives you just an idea of how many different talks and events and things like that are going on. If you'd like information on the events, you can go to the goldspike.org, and it's just a fairly simple web address, Goldspike, not golden, goldspike.org. So you can go on to that. And so if we could go up here, I'll show you one of the events that occurred earlier. And this was the opening of a little museum that's at the west end of the Truckee Railroad Station. And this was what we call a soft opening, because we still have to get the exhibits and things like that in there. We were hoping to have it open for people to see examples of what the exhibits would be like and things like that. Right now, we have a very interesting series of discussions between the town's attorney and our insurance people and the like before they're going to give us the key. Because I thought we had a done deal, because we actually had the mayor there and he cut the ribbon. And so I thought, how can you go wrong? Well, no, there are other things. This gives you an idea of what it might look inside, some of the exhibits that would be inside. And that's just a conceptual view of it. And then we could go on up. And so, oh, damn. I don't have the passport. I didn't bring it along. And we have a book, a passport book that has locations throughout the Truckee and Donner Summit area. And if you buy one of these booklets at the Welcome Center or at the library or at the California State Visitor Center in Donna Park, while you can get one of these books, and at each location you can actually get it stamped. So as you go around, and the advantage of taking these books around is you begin to get a feel for what the history of Truckee is. And so you can really go into a store, a number of these stores, as you go in, there'll be a poster out in the window that'll actually describe what happened in Truckee history at this location. And so, so it's sort of a fun thing to have. And so if you'd like to get it, it's $3 at the Welcome Center. And you can go ahead and get those books. And I think you'd find that that'd be a lot of fun. That arrow there is pointing to the talk that we just gave. And so it doesn't really tell about how much fun I was going to have. This has been so exciting because I'm never quite sure which slide I'm going to see.
I have 5 copies that would have to my car.
Okay, so if you want Katie will actually sell you a copy, or show you she'll go out and bring them in and show you what the passports look. And it really is fun because it gives you a chance to learn about Truckee history and what was going on. And just go on, you can go, actually the Caboose Museum, the old jail museum, they'll stamp it. Cabonas, they'll stamp, and of course Donner Memorial Visitor Center. So it just gives you a fun tour, and you take your time and see what's been going on here in Truckee. And then this is another view of all the talks in typeface that's designed. This is a little bit smaller than legal typefaces when they try to get away with something. So that's it. Yeah. So I think that's it. Ellen? No, thank you.
So I was going to ask for a round of applause for Jerry, but thanks for jumping in on that. The slides will be available on SlideShare, so you can look at them full screen on your own computers. And thank you for rolling with it, with the challenges with the technology. Thank all of you for coming, and none of us spilled the beans on what happened in the game, so you can go check that if you've been recording that.
Okay.
So thank you again.
Thank you, Ellen. Thank you.